Hello everyone and welcome. I'm Joe Beeton, Staff Application Security Researcher for Contrast Security. Today we're diving into our new Contrast MCP server and how it empowers rapid vulnerability remediation with AI coding tools. This new tool allows you to send your contrast data to an AI coding agent or other AI tools of your choice, and that gives you the ability to rapidly remediate vulnerabilities found by contrast assess or scan tools. This open source GitHub repo gives you details on how to configure the MCP server against various different tools. But for this demonstration, we'll be focusing on Visual Studio and GitHub Copilot. There are several ways to configure the MCP server, but the easiest way is just to click this link here, allow in the dialog box, and this will send the configuration to your Visual Studio instance. And from here, you can install it. All you have to do is configure the host API and service keys, username and org ID. And once you've done that, start the server. It starts up in Docker, and from there, you should be able to use it. So now we have Contrast MCP server configured with Copilot. We can take a look at remediating a vulnerability. Here we have a SQL injection vulnerability in a intentionally vulnerable pet clinic application. This is a SQL injection vulnerability where you have the name being appended to an order by part of the SQL query here. What this means is a regular parameterized query won't help, and we'll need to use some sort of whitelisting or other code change like that to remediate it. So this is what the details you get from Team Server. It gives you the path. We'll have the stack trace and the HTTP request that generated that initial vulnerability. So this, along with all the other information like the stack trace, is passed along to Copilot via the MCP server. So what we'll start with is by getting a list of vulnerabilities from the application using Contrast MCP server. What it's doing is, first of all, getting the details about that application back from the MCP server. And now it's returning a list of vulnerabilities. So we have a list of vulnerabilities, but we want to focus on the SQL injection vulnerability we saw earlier, which is this one. So we're going to reference it by the vulnerability ID. So we've requested more details about that vulnerability and for Copilot to then fix it. What's happened here is we're getting more details about the vulnerability. That will include the stack trace, so the full path from the entry point into the application, which will be in the controller class, to the sink, which will be the database call. So you get so Copilot's given the entire data flow through the application, along with the original HTTP request that generated this request. It will be given our how to fix documentation to give it a good way of remediating this vulnerability. All of that information is passed back to Copilot, and now Copilot is using that to find where that vulnerability is within the code base and apply a fix. So now Copilot's identified the vulnerable class in question and is making changes. So it made changes and it's making sure that there's no errors in the edits it's made. Let's take a look at what changes it's actually made. As we can see, it's modified the original SQL query So what's being passed in is this pageable object. That's a Spring object that's being passed in via the pet controller, and that is populated by the sort parameter on the end of the URL. And what's happening here, as that is user-controlled data, rather than that just being appended to the SQL query, which is what the underlying issue of the SQL vulnerability was, it's now being passed through a new method called getSafeColumn, which is checking that against an allow list of two names, which is ID and name. And Copilot has derived that information, the ID and name, from the pet type class, which contains two values, which are the columns in the database, ID and name. And so if any value that isn't ID and name, it defaults to name. So if you added anything else, it would revert to name, and this correctly remediates this vulnerability, because you can't enter anything into this SQL query apart from those two valid fields. And so if we accept the change Copilot has given us, we can see that it has remediated this vulnerability correctly. So now that we've fixed the SQL injection vulnerability, we'll take a look at something a bit more complex. So what we have here is a JNDI injection vulnerability in the email service part of the Pet Clinic application. Pet Clinic application is available on Contrast open source org on GitHub if you want to try this for yourself. And so if we take a look at the vulnerability, what we have is a post request going to the register email endpoint. This is a JSON request body, and if you know about the Log4Shell vulnerability, you might recognize this part of the payload. This is forcing Log4j to make a JNDI lookup to a malicious JNDI server, which will in turn cause a attack to occur. In this case, what would happen is reverse shell will be started on the application. So what we can do is see how Contrast MCP server plus Copilot remediates this vulnerability. So again, we'll start by giving a list of vulnerabilities for this application. So again, it's getting the this application. So we have a few vulnerabilities for this application, but the one we care about is the JNDI injection. So let's see if we can fix that. So it'll be interesting to see what happens, because obviously this is Log4Shell, which doesn't exist in our code base. It's in a third-party library, the Log4j library. So it'll be interesting to see what happens, and if Copilot is able to work that out and is able to then give a valid remediation for this. So it's found the email controller, which is where the entry point into the application is for this vulnerability. So it's recognized that this is Log4Shell, and it should be updating from the vulnerable version to a fixed version. Okay, so that seems to be working. We have a change from 2.13.3 to 2.17.2, which is going from a vulnerable version of Log4j to a non-vulnerable version. So now it looks like it's going to add input validation to the endpoint. So we can see here, this is the entry point into the application we saw earlier, and it's validating the user input to ensure that the Log4Shell payload cannot be entered. So even though the update to the POM would remove this vulnerability, it seems to be going through a belt and braces approach, where it's not just remediating it by upgrading, it's also validating the user input. So we can take a look at what else it's doing. It's also editing the Log4j properties and setting format no message lookups to true, and to disable the JNDI lookup. So this again remediates the vulnerability in a slightly different way. So it's gone for several different approaches, which all do all of these fixes do remediate this vulnerability. So I think we're good. We can keep these changes, and now we have a fixed email service which is no longer vulnerable to the log4shell issue. Thank you for watching this presentation on Contrast's new MCP server. It is available now. Please do download it and try it out for yourself. It works with Copilot, as we have seen, as well as Cursor, Klein, Ada, and any other AI coding tools that support the MCP protocol. Thank you.